Hello everyone. Today let's review another easy question that I solved about 4 months ago by myself. So this one is called maximum number of balls in a box. It's number 1742 and the acceptance rate is pretty high, but the constraints do kind of look a little bit big. So we'll see what we can do in terms of making this as intuitive as possible, which is the goal of my channel. So let's read the statement. You work in a ball factory where you have n balls. So I don't know what n is, just reading this, but we know that they're numbered from low limit, which is an integer, up to high limit inclusive. So the biggest ball is going to be 10, not 11, not 9. And then n, now we know n is equal to the high limit minus the low limit plus 1. So 10 minus 1 plus 1 is just going to be 10, which probably makes sense. So if low limit is 1, so in this case, n would be 15 minus 5 is 10 plus 1 is 11. And then you have an infinite number of boxes from 1 to infinity. Your job at this factory is to put each ball in the box with a number equal to the sum of the digits of the ball's number. So for example, 3, 2, 1 will be placed because you add 3 plus 2 plus 1 is 6, and then the ball number 10 will be in a box 1 plus 0 is 1. So return the number of balls in the box with the most balls. Okay. So again, what we want to do is iterate from low to high, and it looks like we want to sum up all the digits in each integer and then return the one that has the sum with the highest frequency of digits. So, okay, let's look at the example here. It looks like that's what it is, but we also have to iterate from, so inclusive. Okay, so let's try iterating from low limit to high limit. But okay, so let's say for I in range, low limits to high limit plus 1, because Python goes up to not including this, so you have to reset it with the plus 1. So you get from 1 to 10, 1 to 10, inclusive, and then now you can say current is equal to I. And then we want to find the sum of the digits. So let's make a dictionary because we want to map the value to the sum. So let's say, let's make this a string so we can actually add everything inside of it, and say cur value for C and current. It's going to go through this string. So you're going to have like a string of 10, and then you're going to go through 1 and 0 and add all the numbers. So cur value plus equal to int of cur, because you can't add a string. Let's print cur value. So the value is given to you, but now we want to put it in the dictionary along with the actual original integer. So ball number 6, so it looks like the value is the key. So cur value, and then we want to append the ball number, which is, I guess the ball number is just I itself. So let's make this a list. And we also have to iterate from 1 to n, it seems. So high minus low plus 1. Let's print our dictionary to see. With the most balls, that would be 2. Why is it 2? So I dot append current value, or current value dot append I. So 2 is going to be, why is 2 the one with the most balls? Oh, the number of balls in the box. Okay. So whatever frequency that is. Okay. So here the biggest frequency is 2, because this is 2, this is length 1, this is length 1, this is length 1, 1, 1, 1, 1, 1, 1, 1. So let's call this result. So I guess result equals max of result in length of the cur value, which is this list. As it gets bigger, you're going to update result if it's bigger than the historical result, and then return the result at the end. So hopefully this is correct.
Okay, cool. So it passes all test cases. It's not the most efficient, but this is a quick, dirty solution I just came up with myself. So hope you enjoyed it. Let's see if we can get a better one. Okay, runtime increases. Now if let's max function in Python actually is O of n. I found that out recently. So let's say if length of d curve value is bigger than result, then result equals to length of, let's just call this length of d curve value. If n is bigger than result, then result equals to n. That should be a tiny bit faster. Okay, a tiny bit faster. Let's make it even faster. We can probably just sum this up. I'm not going to do that in this video because this is meant to be a short video, but hopefully this is helpful, and stay tuned for more.